Let's take a look at generative adversarial networks, in short GAN or GAN. These are also deep neural network, and this was introduced by a team of researchers from the University of Montreal, a rather recent advancement in the deep neural networks area. Now, GAN is a significant improvement in the deep neural network area because it has the capability to understand any distribution of data and produce the same. In other words, GAN could produce creative artifacts like pictures, paintings, maybe even one day movies. As GAN can do this, this will bring it much closer to human capabilities. Generally speaking, the act of classification or regression by any artificial neural network is mostly discriminative in nature. So, for example, given a set of features, the network predicts it belonging to a certain class. So if you draw an equation, so you could say that a set of features X and a class Y, the artificial neural network predicts the probability of Y given a set of X. Now if you flip this around, then it would become a generative model, because now given X, it would actually predict the class. In this case, prediction would be generating the class. So GAN uses these two techniques. So it has two components, and both of these are different variations of CNN, which is convolutional neural networks. The first one is called the generator. As the name goes, it generates images, or it generates a class of distribution as output. A second component is called as the discriminator, and this behaves much like a classifier in our artificial neural networks. Now let's see how GAN really works. So the first step is to feed random noise or random numbers from a normal distribution into the generator, and this CNN produces an image. Now here you have a nice looking 8, but in the first iteration this would also look pretty much as noise. Now this image, along with the training set, which is the actual image, is fed to the discriminator, much like the input-output pair when you would be training a CNN. And this discriminator performs the classification and tells us whether this fake image is real or fake. Now, along with this classification in a GAN, the gradient of the error is fed back to the generator using backpropagation. In other words, an advice is given to the generator as to how to improve this output, which would resemble the training set, and hence the entire network can reduce the difference between the real and fake. So theoretically, at some point, the fake image would look exactly like the training set, and hence the error would be 0. Now, given the fact that GAN presents significant opportunity for the deep neural networks, and this also means that there could be some reshuffling and retraining required for the current workforce.